Up there at the front of the room.
Yeah, you're broadcasting the front of the room. So, welcome everyone to the September edition of the Cincinnati Meteor Meetup. I am one of the co-organizers, Josh Owens. We invited Dean Radcliffe to speak about promises and drink beer on camera.
Cheers, Cincinnati.
Cheers. Yeah, so I think you can go ahead and get started whenever you want. Just share your screen, and we'll watch your slides. And like I said, you're up on the screen up there.
There I am. Cool. Hey, guys. So just so I can tell, like the latency in our connection and stuff, and so that we can sync the beginning of the video with the audio, we're gonna do a 1, 2, 3 clap. Okay, so everyone ready for that? Okay.
Sure.
1, 2, 3. That was better than Toronto.
Nice.
And I was there in person at Toronto. All right, thanks everyone. I'll also, since I can't see your faces, I'll shout out to Josh. Okay, so if I have any questions, I'll kind of single Josh out a little bit, just so that goes smoothly. All right, so let's see the way to do this here. I guess I can do entire screen, and then you see this presentation, and then I go full screen. And are we good? Hello?
Yep, we're good.
Okay. Lots of big text, bold. So, hello everybody. This is my first remote presentation, but since Josh and I have been doing things remote for quite some time, I'm sure it'll go just as well as those podcasts and such. I hope you enjoy those if you see them. I'm Dean Radcliffe. I work with OK Grow, which is a company that Paul Dowman and Ben Strahan work at. And I really enjoy doing Meteor full time. And I'm here to talk about promises, which I call the unsung heroes of async in JavaScript. I can't ask for a show of hands. Perhaps some kind of noise if you've used promises before.
Like a few people.
Okay.
One maybe.
Well, I'll get into the whys and hows of them, perhaps even a little more in depth than you may have thought about them if you've just used them casually. But first, I think it's important to kind of know how to think about promises. And promises are in maybe a strange JavaScript concept or Meteor concept to people, but we use them all the time in daily life. So here's a scenario of a promise in which I bet you, Josh, hypothetically bet you $20 that the Reds won't beat the Cubs at all this season. The Cubs will not lose to the Reds this season. Anyone a baseball fan want to say whether they'd take this bet or not? Well, I happen.
Huh? Someone taking it?
Wow. And I have an idea why you might take it. That's why I called it a hypothetical bet. But why would you take it? And who said that?
Bruce.
Bruce? Why would you take the bet, Bruce?
Just because it's almost 50-50. I mean, it's probably 46.
Yeah.
Can you hear me?
In fact, I did.
They play several times.
And there's a Cubs-Reds game tonight. That's kind of interesting coincidence, kind of making that Cincy-Chicago connection stronger. So this is a bet. There's nothing strange or unfamiliar about making a bet like this. And what it means is that we're waiting for an eventuality to happen. It may have happened already. In this case, in fact, it has happened already. But a upon some eventuality occurring, an action is going to take place. So in fact, if I were to take this bet, I'd lose my money right away. But these are the two promises that are going on in plain English. The season begins, then the Cubs lose to the Reds, and then the season ends, and I have to pay you. Or the season begins, it ends, and there hasn't been a loss in the middle, in which case you pay me. So promises exist to clarify certain semantic problems that can occur when you make bets like this. For example, if Cincinnati had already lost, or if Cubs had already lost to Cincinnati, what would happen to our bet? And if what we're really betting on is the top sequence of events to happen, then I have to pay you, because you can prove to me by showing me this record that regardless of the date that we made our bet, there was the beginning of the season and then a loss to Cincinnati, and then the end of the season. So think about promises as bets that may already be a lost cause. So if we really want to make this interesting, this very top line here, times Chicago shut out Cincinnati, 1 so far, times the other way happened, 0. So we could make a bet. That would be a more interesting bet if we bet on something that hasn't concluded yet. But there you go. And it's not quite 50-50, but I'm actually not a huge baseball fan, so I'm not trying to like say anything about that. Just the Cubs happen to be having a good season, which is kind of remarkable. So that's basically the nature of promises. They are events, but they can occur at any point in time. So they may have occurred in the past, and when you can make something contingent upon a promise, what that means is that thing, like for example the payment, has to happen ASAP if it's already been decided, right? So if someone shows me that my bet's already lost, I don't have any reason for postponing. I mean, if I'm finishing my lunch, maybe you'll let me finish my lunch, but then I have to pay you. And if it hasn't happened already, a promise represents the soonest possible moment once it happens. So that's one way to think about promises as events. They also can serve as values. So for example, the value of the win-loss record once a loss occurs. You can create a promise for that value, which kind of comes along with an event occurring, but the value may already be known. It may be being computed right away in this turn of the event loop, and I'll mention a little more about the event loop later, or it may be unknowable. So a promise can be set up for, maybe we make a promise for man settles on Mars. Well, if we really want, we can make a promise upon that, but we may want to combine it with a timeout just in case this doesn't happen in either of our lifetimes. We might want to place a bounding box on it, but that's irrespective of whether you're using a promise or not. You can make a promise for that happening, even if it may never happen. So the neat thing is that a promise can represent an entire chain of events, including branching possibilities. So while you ponder the code on this slide, I'm not going to read it aloud. It does use ES6 function syntax. So that's just like regular functions, except without the word function and without the parens in this case, and without the word return. So here is a chain of things that will do something conditional in the second step. And I like to compare promises to jQuery. This is my new favorite analogy. So when you're using jQuery to select some DOM elements, and then you drill down, and then you drill down a little bit more, then you go up to the parent, everything is just really smooth. You can just keep chaining on things. With promises, you chain on actions. And everything is really nice as long as you keep using the return value from the previous thing. So in this case, we kick off with a promise for the first step. We create a new variable, all steps, that is this entire series of steps, and then using some magic we'll talk about later, we can say promise.await all steps, and then make sure that the lines of code, the hypothetical lines of code below promise.await all steps, don't run until we have every single step in that chain completing. Any questions on this? All right, I will move on and maybe save questions for the end since it's hard to gauge. Am I still connected to the audio here? Oops.
Yeah.
Okay, great. All right, so one or more conditions or actions, going back full screen. All right, so what does our bet look like in promises? Well, what I really like here is line 2, promise.race, and then 2 arguments, Cubs lose to Reds or the season ends. So we can think about the 2 promises we made earlier, the 2 halves of the bet, and we can say what we're really racing is whether the season ends first or Cubs lose to Reds. So just like jQuery has really neat ways to combine DOM selection, the Promise API has really nice ways to do things like promise.race or promise.all. And so we can begin the season, and that's a function call that returns a promise, and then chain on a race between Cubs lose to Reds and season ends, and then based on whether the value that we get is truthy or falsy, we can trigger the I pay you or you pay me. So in these examples, all the function calls return promises, and in order to set something like this that works, the Cubs lose event should return truthy, the season end should return falsy, or throw or reject. And we can talk about those other things that promises do when an exception is thrown. But that's basically it. You're racing to eventualities and creating a chain for all of them happening. So really, with this nice, almost jQuery-like API for async, I think that they're the unsung heroes of async. Meteor's reactivity is we already know how wonderful that is, and that is another way to allow events to occur one after another in time. But before the Meteor community came around with its reactivity, there were callbacks everywhere. And what promises do is improve upon that by making the contract of behavior very explicit, unlike callbacks. And I'll explain a little more about that. So a promise can resolve or reject. There's the happy path and there's the sad path. They're called resolve and reject, and its state will change only once. Any given promise will only change once from a state of pending to a state of fulfilled. And then in order to pass a handler for the happy path, you pass it in the first position to p.then. Typically when you do .then, you only pass a single function, but the truth is you can pass a success function and an error function, or you can split it up as shown in the bottom where you specify a happy path function and then any number of steps in the chain, and then at the very end of the chain you can tack on .catch, and that .catch sad path handler will be triggered if anything above it in the chain either throws an exception or rejects its promise. So it is certainly nicer than doing the callback version if error is null. Okay. So this is how promises work. You create a chain of them with .then, and each step in a then chain returns a promise for all things that came before. And it doesn't get much simpler than this. Promise 1, .then, promise 2, .then, action 1, .catch, action 2, if it were there. Each step in a then chain may either return a value directly, or it can return a promise for a new value. So if you have a value available synchronously, you can return it in a then chain. So just like jQuery wraps regular DOM elements and kind of promotes them to full jQuery elements, promises can take a value that's available immediately and promote it to a promise, or it can just deal with a promise. So each step of the then chain, if you return a regular value from it, it'll be promoted to a promise for that value. And so your happy path parts of the then chain can return a promise or an actual value. They can also raise an exception or return a rejected promise. So in this case, I made the promise.race condition more explicit, where if the Cubs lose to the Reds, then we'll return a truthy value, for example, the record of the two teams. And if timeout at season end, we'll create a promise for the end of the season, and if that season end comes, we'll throw an exception. So if the exception comes, you'll fall into the .catch block. And so our way of saying, I'm betting that the Cubs will be undefeated. Well, if the season ends and it throws an exception, then the you pay me method will be triggered because it's part of the catch block, which catches the exception. This logic can be a bit funky if it's your first time seeing it, but just like jQuery was funky the first time you used it, you can't really argue that this is pretty darn concise. If you don't know what each of these means, it might take a little time to figure out what they mean, but there's a very small amount of noise going on here. I hope you guys will agree. So one of the best things about promises is how they deal with exceptions. So just like a value can be promoted to a promise for a value, an uncaught exception can be promoted to a rejected promise. And so what that means is that an uncaught exception occurring in a .then block is okay. You'll just fall through to the catch at the end, which can handle errors for the whole chain. And this improves vastly upon how you have to do exception handling if you're using callbacks. I think that's what the next slides are about. Oh, no, win. It's a baseball comic relief cat picture. Or should I say cat pitcher? Cat pitcher?
It's terrible, terrible.
All right. All right. Is that the Reds or is it some other team?
That is definitely some other team. Devil Rays.
Okay. Fail on localizing the cat picture to the cities that I'm presenting this in. All right. So a real problem that promises solve has to deal with, have events happened already? So in this case, let's say that we have a document that is already loaded. All right. And we have some code that runs each of these three different versions. Which one of, and we pass a callback, essentially, a function to be run to each of these three ways of doing DOM content loaded. Josh, do you know which one of these will actually fire if the document is loaded already? Do you even want to have it?
No.
That's right. You don't want to, because it's a trick. But it's not a trick question because I'm trying to trick you. It's a trick because only this one does it. Not the second one, on ready, which is just like adding an event listener for the DOM content loaded event, but only the middle one. This one in the middle behaves like a promise in the sense that you can call it at any time. So why don't the other two fire? It's because adding an event listener, it's like saying, with that bet example that we had earlier, the timing of when you add the event listener matters. And with promises and with these bets that we make, we don't want the timing of when the bet happens. We want something to follow the document being loaded, and we don't care whether it's loaded already. We just want something to follow it. That, my friends, is the use case for promises, right there. So imagine that somebody gave us something called a DOM content loaded promise. Well, I showed you that you tack on behaviors to it using .then. So if we had a variable called DOM content loaded promise, and you passed in your little callback there, what would happen right away in your JavaScript console is you'd get a promise back, and it would tell you that it is a resolved promise. And then those little 5 dotted lines, that's not a game of hangman, that indicates that the next turn of the event loop occurs, and then the words "I'm ready." So an infinitesimal amount of time passes between getting the promise and the promise's action firing. But it is significant that it is not firing in the same turn of the event loop. And I'll tell you a little why later. But basically, I mean, it's this simple. If your document is loaded infinitesimally as soon as possible after your callback is run, if your document is not loaded, well, you get a promise back right away. And the promise is for the chain that you just created, but that entire chain is pending because everything hasn't happened. So you get this object back, and then the event loop moves on, and it's loading, and it's loading. Boom. Now it is finished loading, and then as soon as possible after it actually loaded, you get "I'm ready." Pretty neat, huh? So now I get to be a little bit grumpy, but I'm actually decided to spend less time on this grumpiness and say, you can look up this grumpiness by reference. And when I did this Meteor interview, if you ever go to meteorinterviews.com, my boss Paul and I talked at length about promises. And so in the show notes for that, I point you to a presentation where I copied all of this information from. But in a nutshell, when you use callbacks, you assume that things behave a certain way, but they don't always behave that way. So one of the little callback trivia is that you have an ERR object and a result object typically that comes back in what's called a node errorback, ERRBACK, typical callback handler for a node situation. You're never supposed to get an error and a result, but there's nothing to stop a library author from giving you an error and a result. Not saying it's a good idea, but the point is that the contract is informal about how callbacks work. The contract is formal for how promises work. So you will, for every library that takes callbacks, every 10 library that takes callbacks, you'll find at least one of them breaking some of these assumptions. And they can be very hard to track down. If you're using promises, you never have to worry about, for example, if the callback you're passing in is going to slow down the code in the current turn of the event loop. So, promises formalize this point number 1, must never execute on the same tick of the event loop. The promise, each step in a .then chain is guaranteed to execute in a later tick than the other one. And the reason why that's good is because it allows in a web browser, allows the user interface to continue processing events, and in Node, it allows for the server to continue processing. So it's good. It's good. Now, if you're not writing a library, you're just using async libraries, you'll be really glad that you don't have to do this. So if it represents 2 async steps. Good luck trying to find them. They're buried in here amidst the words function, return, try, catch. And they're do stuff 1 and do stuff 2. And if you really want to do proper exception handling, you have to check for the error, and then you have to call your steps in a try catch because maybe that library is misbehaved and it doesn't populate the error. It actually throws an exception. So here you see 2 steps in a chain, each one wrapped in a try catch, each one with if error, return, CB error, and it's just horrendous to look at and horrendous to write. And I bet you none of you, and I don't do it either, write your async code this way. You take shortcuts. But the fact is, you're taking shortcuts. This is actually what you need to do to write bulletproof callback code. Want to see what you have to do to write bulletproof promises code? There it is. So just as bulletproof, far easier to reason about. And my other comic relief point is if you ever play buzzword bingo on a tech talk, you should, or like a drinking game out of listening to tech talks, anytime someone says, makes it easier to reason about, you have to drink there. So on that note, I'm having another sip. So that is what's right with promises. I have a little tangent to go into on the event loop, and it explains a few things a little bit, but I generally wave my hands a lot during this talk and like walk up to the board and gesture. So I hope this will play out similarly. Oh man, it's hard to think about even doing it. Does anyone want me to go into how the event loop works, or can we come back to that? If
I'm to go into it. I think maybe you can come back to it.
okay. All right, I'll come back to this after a couple of slides. Okay. So in a nutshell, there are only two ways of coding JavaScript: that's synchronous style and asynchronous style. What gets us confused is that there's different ways to do async. And to some extent, you can actually convert between them. So in the async family are callbacks, are promises, our good friend reactivity from Meteor, and on the server, fibers. I need to update the slide because there's actually a fifth one in ES 2015 called generators and yield functions. Not going to go into those now, but you can convert between these. So for example, if you have a callback function and you want to run it in a fiber, the lower right example illustrates using meteor.wrap async, passing it a callback function and receiving a fiber function, which appears to block so that you can use it synchronously. Also, if you have a callback function and want to turn it into a promise function, there's a function called denotify, as in like Node.js style callbacks. You can denotify a callback function and get a function that returns a promise, similar to the way that Meteor Wrap Async works with fibers. The denotify style will work on the client and the server because promises work on the client and the server. The fiber version will only work on the server. Totally fine to use it. It's really nice when you're using fiber-based libraries that just appear to be synchronous. But I've started to think that it's a bit unusual that Meteor, which tries so hard to be isomorphic, has some server-only constructs that are different. But to some extent, you can convert back and forth between these. Now, the reactivity style is a little bit different example to show, not as simple as turning one function into another kind of function. So I'll illustrate that a little bit more later. Right here, in fact. So let's say that our goal is to keep an uppercase variable in sync with a variable called lowercase. And we know about reactive vars, right? They're like just like a session, but only one key of a session. So let's say that we had two variables. Don't be disturbed by the let syntax or the omitting the parentheses after new reactive var. It's just ES 2015 syntax. So we have two reactive vars, and to keep them in sync, you could probably imagine how this would have been done, but I was going to ask you to do it. But here's an example of an Autorun which gets the value of the lowercase variable and then sets it, the uppercase of it, into the uppercase variable, right? So if we do this, we know that sometime ASAP after setting lowercase, uppercase will reflect it, right? Well, we can actually get the same behavior if when we call set lowercase, if that returned a promise, we say set lowercase and then set uppercase. Set x dot to uppercase. So the two are equivalent, and you might just prefer one or the other for the kind of problem you're working with. Sometimes I find it's very handy at the time that you're doing something to do something else. Other times I want a more pub sub where any other auto runs here that are depending on lowercase, there could be 100 different auto runs that are looking at this lowercase variable. Nice thing about reactivity is you set it once and all those other auto runs will fire. But for simple cases, you might just want to use a promise syntax. My point being that these at runtime, these two behave exactly the same way. So I want to illustrate a pattern that has gained a little fame in the Meteor circles lately. We've heard that you can now return a promise from a Meteor method. And if you've followed this about promises, you might wonder, like, what does that mean? Like, return a thing that waits around for an indefinite amount of time from a Meteor method? Like, what the heck does that mean? Well, I'll show you the code, but let's break it down. Returning a promise from a Meteor method. Well, a promise is an eventual value, right? So you're not returning a promise from a method, you're returning an eventual value from a method. Or in other words, you are eventually returning a value from a method. And that's the same thing that happens if you have used meteor.wrap async on some sort of callback function. You will eventually return a value from that method. So returning a promise, the caller doesn't receive a promise, they receive a value. The trick is in what actually happens inside the method. That's different. So I'll show you the code. So here you see some Meteor methods defined. And let's say that we want to be able to call a method on the client that gets the time, let's say 5 seconds from now. Well, that does mean that at the time that the client calls it, it'll have to wait. We want to make sure that that wait is non-blocking. But as far as the server goes, we can create a promise for that future time. But in order to return the promise for the future time, we have to await the promise. Otherwise, we don't have the actual instance in time to return. So the outer block of this Meteor method is wrapped in promise.await. And promise.await has to be given a promise or a chain of promises. I hope the ES 2015 syntax for method declaration isn't bothering you. Let's just look at the return promise.await. Now inside of this, you need to create a promise. And I haven't shown you how to create a promise. Create a promise by declaring new promise, calling the constructor. And what that does is it gives you, well, you must pass a function to the constructor for promise. But what this gives you, once you accept a variable called resolve in your function, is a scope. So all this empty space here is an area where you can do any kind of crazy callback code you need to. But at some point in that callback code, if you call resolve and pass it the value you want returned, well, you will have created a promise for that future value. And the future time method will await it. So here is some set timeout code that fills it in. Set timeout, the first argument to set timeout is a function. The second argument is the delay. The delay is 5 seconds from now. when that 5 seconds elapses, we say, hey, it's the future now. And then the resolve function is called with new date. So it's a few layers, and this might look a bit weighty the first time you see it, but it really builds up nicely while you're writing it. You're awaiting a promise, you're creating a promise, and you're resolving the promise. That is how you return a promise from a Meteor method. And it's, you know, particularly useful when you're dealing with NPM libraries, other libraries that return promises. All right. We have a few more things to go, and my daughter will be joining me for this, so you might hear some of that in the background.
Hey, we had a question. Hold on.
Hey, Dean.
Mm-hmm.
So a good use case for this might be if you're. I was trying to think. I'm like, I know there are situations where I've hit this before, and this would have been useful. Like if you're hitting an API from the server side, like maybe you're pulling data from an API, but you want to pull it from your server instead of your client, and you want to do it through a method. This is probably a good way, right?
Yeah, absolutely. And like, there's nothing wrong with using Meteor.wrap async, but that is limited to circumstances where the callback function behaves a certain way. And I just published a utility that looks up versions of packages on over DDP, and the callback arguments and the shape of it was just wrong for using wrap async. So using this pattern, you can create a promise around any gnarly code. No matter how gnarly that callback code is, you can create a promise around it and then await it, and it's just as if you were able to do Meteor wrap async. So yeah, APIs. Unless it's an HTTP API, right? Because on the server, Meteor's own http.call doesn't need a callback. But if it's something like a GitHub API or something more complicated, then definitely. Good question. What am I showing here? Oh yeah, that you can, here's a refactoring of this where it's not also nested, but you create a chain of promises, and this just shows like a different approach where your chain, the first two lines of the chain create a promise that resolves after 5 seconds with the new date, and then it tacks on a little .then and .catch, and then does return promise .await action. So this will do effectively the same thing, but you know, just a different structuring of the code. There is an async sheep. I wish I had a joke to go with that. I do, but I don't think it's going to go over well. I'm revising the joke. It's in progress. But I hope you enjoy this black sheep. Sometimes I feel like a black sheep for using promises in Meteor. But hopefully there'll be more of us running around soon. So that was like talking about defining a method that, you know, eventually returns a value. So how do you call the method? Well, this Meteor.promise, it doesn't exist by default in Meteor, and it does exist if you have included a package called okgrow::promise. It patches the Meteor object. Maybe I have a few regrets about that, but not really, because it's been super helpful to people to basically have an API that works on the client. You don't need it on the server because you don't need to meteor.call a method on the server. But on the client, you do a meteor.call. Of course, you pass a method name and then some arguments. In the last position, you pass a callback. Well, I thought that Meteor.promise could be the version of that uses promises. So instead of passing a callback, you are returned a promise that you can chain onto. So that method we defined, future time, here is the client side if you're using okgrow::promise in your Meteor app, you do meteor.promise, future time, and then you log it. And that's it. Another thing you can do, kind of creating a chain of things together, suppose that you want to log the time now and then log the future time. Well, here is an example of promoting the present date to a promise. The first line says promise.resolve, so resolve immediately with the new date. What that does is it promotes the date object, which has no .then method on it, into a promise, which has a .then method. So with the new date, we can log that right away. And then we can return a promise for the future time. And when that comes back, we can log that. So take a look at this, and I'll just kind of be silent for a second while you compare the output, remembering that the dashed lines are different turns of the event loop. Compare the output to the input, where the output consists of the current time, then the promise for the entire chain that you've created has been returned, and then 5 seconds later, the promise for the future time, the server has responded with its future time, and then that was logged too. So this also illustrates that the value that is returned from one step of the chain becomes the first argument to the next step of the chain. So assuming we had a function called log that did a console.log, well, it received the new date, and then it received the future date as an argument. Any questions here? I'm going to pause here.
No? No questions?
Cool. So then there's one other little trick here just to illustrate the fact that the thing returned from one step becomes the first argument for the next step. So look at the word future time, the string future time, the method name that you're calling. Well, I'm not saying you'd want to do this, but you can certainly return that string future time from one step, and then it gets passed into the meteor.promise method as its first argument in the next step. And it was just kind of a ridiculous code golf that I did here. I'm not saying that it's better to split that up into 2 steps. Just wanted to show you that you can intersperse. There's room for creativity in the way you create these steps. And then, man, I was going to find another comic relief cat picture, but there wasn't any on the internet today. It was plumb fresh out of cat pictures. I don't know. They should do something about that, Josh. All right, I hope there were groans there. I didn't hear any groans, but I can kind of feel them. All right. So the OKGrow Promise library is, I think it's as awesome as Sweatin' to the Oldies, maybe a little more awesome. What I didn't show was how you go from a promise to reactivity. And the key to that is this question: can the resolution of a promise invalidate a computation? And I swear to God, I'm not just trying to sound smart and use like long, confusing words. The code might actually be more intelligible than that question. But definitely, you can set up a promises resolution to invalidate a computation. So what's the use case for that? Well, suppose you have a helper that is going to call a server-side method, and you want that helper to return a value into this text area. Well, I've definitely had other people be inside a helper, and they're writing some stuff, and then they have to make a Meteor method call, and then they're like, but wait, I can't, how do I return the value of a method call from a helper? And you can't. What you have to do is create a promise for that method call and then pass it through this function that I'm going to show you. So this is the use case, that you have a helper called Meteor Promise. So how do you set up Meteor Promise? Well, you'd like to do something like this where you do some reactive stuff, depend on some variables and whatnot, and then do a Meteor dot call or a Meteor dot promise. But what you need to do with this OKGrowPromise library is actually define a helper function just as you would normally. But then when you set up the helper map, Meteor Promise becomes a reactive promise. You have to wrap your helper function in reactive promise. When you do that, you can give it some text to display while you don't yet have the promise. You can also give it some text to display in the error condition. And so it's just a little wrapper that allows you to return a promise. So here you're seeing meteor.callPromise instead of meteor.promise. This is what they both work in the library of the current version, but I decided to follow a convention because there are other things that you may want to have promises for. So meteor.promise, I changed it to meteor.callPromise, but currently you can use either one. So I'll show you a site that kind of shows you everything you can do with these promises. So we got okgrowpromise.meteor.com. And here it talks about what is implemented in this package, including http.get, http.post, all those HTTP verbs. There she is. Hi, Sierra. And then I'll let you go through this code here, but here is an example where your client template has a server call with latency, and the code behind the template wraps a helper in reactive promise, a helper that returns a promise, and you can go and type stuff, and you'll see the loading indicator. The loading indicator comes from where you've passed reactive promise, your helper function, right there, and then your loading text. And you return a promise from it. So this one includes a little extra latency, just so that you can see that it's a server kind of call. In these other versions, you don't actually use latency. We haven't added any additional latency. It just goes as fast as it can come back from the server. And in fact, this one is actually doing several round trips to the server because we're chaining promises. We're adding the values of the text boxes, and then we get that back, and then we're adding the word server says to it, and then we're adding that back, and then we're doing the smiley face. So every single step, this is like the first server call, and then the promise adds this onto it, and then it becomes that. Also, you have had HTTP GET, where you have to pass a callback. GET promise allows you to get a promise for it to do .then and .catch. And so if we get a file from a site that doesn't throw an error, we see the contents of it being put there. And in this case, we're not using a helper. We're just forcibly updating the value of that with jQuery. And in the case where it throws an error, then our catch block is being hit, right, in either of these cases. And then you can get even crazier with this. So the fullest example here, and the one I'll end on, I think, is the case where you're writing a blog post and you want the blog post to have a link in it. Maybe you're passing the link to share it, the social sharing Meteor package that has a link. I'm not exactly sure how that works. I might be confused there, but suppose you want a link to your article to appear in the article. Well, you need to create a chain of events here. You need to, once you start publishing the post, you need to kind of note that it's in progress, the publish, and then you start off with some placeholder text, you publish the post, you create a short URL for it, and you merge it back in. I don't actually like the way this reads. It's a little more confusing than just doing the example. So we can hit publish post, and a chain of promises will be put into effect where we publish it once without having the short URL, and then we get the short URL, and then we merge that back in and we republish it. So you can go through the code in here to see a chain of promises that is used to do that. So you can, it can be a really better set of control flow than basically any other way that I've used. And this isn't using Mongo, for example. Josh and I have had some conversations where, the question is, and I would be happy to answer questions from you guys about this. Like, can't I just put it in Mongo and let Reactivity update these fields? You might be thinking that would totally work, and you can. It's just that some of the time you don't need to persist things in Mongo, or you don't want to. This is not a replacement for Reactivity. I think it's a supplement. Meteor runs on top of JavaScript. Promises are part of the JavaScript standard. And so Meteor couldn't keep promises from you even if they wanted to, any more than they could keep set timeout from you. It's just part of the language now. So I figured that I would do this work to show you several use cases for promises, for the same reason that when you're traveling in another country, it's good to have a guidebook that just explains your basic phrases, Donde está el baño? I wanted people to have a guide to using promises. If you don't have to use them, fine. If you do have to use them, let's make sure you have a guide to use them well, and also have a Meteor package that not only gives you a promise that's available in every browser by pulling in Meteor's promise package, but also just one that gives you some conveniences too, and that's open to community improvement, because we all know the best way to get something into Meteor is sometimes just to put it out there yourself, right? So that is what I have for now. Any questions, people?
Anyone have questions? You got a well done.
Well done.
Questions? Yeah, we got one.
That's a great question for promises, right? Cases where promises don't maybe anti-patterns, things you should avoid when you think about using patterns or callbacks or speed.
Were you able to hear that?
No, could you repeat, summarize?
Yeah, are there any anti-patterns or any places where you wouldn't want to use promises?
That was a no. No, I don't think there are any places where you wouldn't want to use promises where there'd be any drawback to using them, because like I said, they're equivalent to callbacks except for being standardized. So like I actually think they are a real improvement over using callbacks, but if you're getting by without them, you don't have to use them. But when you do start using them, you'll notice that they bring a standard contract of behavior, and it'll be like, once you start using jQuery to query DOM elements, you don't want to go back to the old one. That's what I predict.
Any other questions? No? I think that's it.
All right. Thanks for letting me do my first remote meetup. I wish I could stick around for you guys, but I'm on parent duty.
Well, thanks for giving the talk. We really appreciate it, Dean.
Yeah. Thanks, Josh.
All right, and if people want to find you, where would they find you at on the internet?
Yep. I'm on GitHub. I am Denius. On Twitter, I'm Denius Dev.
And then you're in the Meteor Club Slack chat room too, right?
And I am on there as often as I can.
And then also, just for anyone that wasn't here, I'll say that's too bad because Modulus sponsored. They brought pizza and cookies and brought a bunch of T-shirts. So.
Oh, bring one for me at Space Camp?
Yeah, I will.
All right.
All right, man. Thanks.
All right. Thanks, Josh.
Bye.